Hello everyone, welcome to Cognify. So in today's video, we'll be looking at functions. Okay, so we are given a function defined, two functions. So these two functions are defined as f of x is equal to x squared minus 2, and the other function is g of x, which is 3 to the power of x. So we've got two functions, right? One is a parabola and the other one is an exponential function. So let us look at the questions that follow. So in the first one, we are required to sketch the graph, right? Sketching the graph of both functions on the same set of axes, and we need to clearly indicate all of the intercepts on the graph. So let us first define the few terms that we're going to be using, right? So for f of x, I'll just separate it here first. So for f of x, we're going to be using these values, right? X is equal to minus 1, 0, and 1. Okay. Same applies with g of x. Minus 1, 0, and 1. So now, what are the corresponding outputs for each here? That's what we want to find, right? We get those corresponding values, and then we'll be able to plot our functions. So now let's take this one step at a time, right? So let's look at f of x first. So for f of x, okay, let's see here. So f at 1. Okay, let's start with these values here that we listed. So f at 1 is equal to x squared minus 2. Okay, we replace the x with a 1. So here we have minus 1. Next one, f at 0 is equal to 0 squared minus 2, which is equal to minus 2. And lastly, f at minus 1 is equal to minus 1 squared minus 2. So this is equal to 1. What you'll notice is that these two values are the same, right? And then lastly, g of x. So what do we have here for g of x? So g at 1 is equal to 3 to the power of 1, which is 3. Next, g at 0 is equal to 3 to the power of 0, which is 1. So any number raised to the power of 0 is always equal to 1. And then lastly, g of minus 1. So 3 to the minus 1, this is equal to a third. So now we've got our points, right? So we understand what our coordinates are. But let's quickly write them down so that we have them ready. Okay, so from here, right, we check for this one here. I'm just going to write it as a coordinate, right? So we'll have minus 1 and minus 1. Then we have 0 and minus 2. Then lastly, we have 1 and minus 1. And then for our other function, so 1 and 3, 0 and 1, and minus 1 and a third. Okay, so let us plot this. So this will represent our function, our axis, Uh, this is going to be a rough sketch, so it won't look perfect, but to give you an idea of what the function looks like. So let us quickly plot our points here, right? So we'll have 0 here where the axis intercept. So when we're plotting, right, we need to look at our values. What are the upper and lower bounds? So for the x, okay, for the x values, okay, our bound is from -1 to 1, okay? And then for y, it would be what? We're just going to be looking at, for the f of x, it's, okay, -1 to -2, and then for the f of x is a third to 3. So we're going to expand it from the lowest value, -2, which comes from f of x, and then this goes all the way to 3. Okay, this way we can put like realistic values so that our function is drawn to scale. Okay then, so let us quickly put these points here. So we have 0, and then I'm just gonna put a half here, a 1, 3 over 2, and 2. And then towards the left, it's gonna be minus a half, -1, -3 over 2, -2. And then for the y, we'll have -1 here, and then -2 here, and then you'll have 1, 2, 3. Hopefully it looks accurate enough. But anyways, so now let's use the points that we have here, right? So let us use the same color here, right? So for the f of x, it will be represented by white. So the coordinates we have here, what? 1 and -1. So if we check here on our axis, 1 and -1 is -1 on the x-axis and -1 on the y. So it's going to be this point here. Next point, so got this one done. Next one is 0 and -2. So at 0 on the x-axis and -2 on the y. So it's this point here. So now we can join our points because 2 points for the parabola, 2 points won't be enough. So let's get one more point. So this one here is taken care of, right? Let me just brighten this a bit. I'll just make this bigger so that's clearly visible. Okay, the next point is 1 and -1. So we've got 1 on the x-axis and -1 on the y. So put that point there. So we can see here that our function, we can see what the shape will look like, right? Given that it's a parabola. You can see here that at this point here, the parabola is basically changing direction. Okay. And note that our function, parabolic function, right? The constant, so this value here, right? The 1 is a positive. Okay, it's a positive value. So a function will have this kind of shape. If that value was negative, then it will be like that. Okay. So this one here applies to where a is greater than 0. So it's a positive. Okay. And then here, if a is a negative value. Okay. So now let us join our points. Okay, so it's gonna look something like, not looking too accurate, but we get the idea. Yeah, it goes in that direction. So this point here is the turning point. Okay. So the turning point is a point on our parabolic function where it changes direction. Okay. Or where there's a change in concavity. But that is basically it for parabolic function. The next one is our exponential function. So with the exponential function, we represent it with a different color. So we have 1 and 3, right? So 1 on the x-axis and 3 on the y. So we've got that point. Got that point ready. So that one is taken care of. Next one is 0 and 1. So at that point there. And then lastly, we've got -1 and a third. So -1 on the x-axis and a third on the y. So it's going to be around there. So with the exponential function, what you need to note is that the function is bounded. Okay, what that means is there's a boundary that it will approach, right? But it will never touch. See our function here, 3 to the x, right? Do you think we would ever get a negative output for any values of x here? Let's say we put a negative, extremely negative value of x. This function here is just going to approach 0, but it's never going to touch it. Okay, so now function will look something like this. So it goes to those 2 points and then up there. So it's not going to cross this boundary here, right? Where y is equal to 0. And that's basically it, right? So for this question here, we took a bit of time, but I did that intentionally, right? So that I take you through each and every step of the process. So now we can then proceed to answering the questions that follow. Now let's see. So let us quickly just move to right. So that question is taken care of, right? Clearly indicate all intercepts. Clearly indicating all the intercepts with the graph. Okay. So we need to show all the intercepts. So before we move on, let's quickly confirm this, right? So now let's see, we've got one intercept here. We just need to note that down as 0 and 1. The next one is here at the turning point, which is another intercept. So there we'll put 0 and -2. And then another one is at this point here. Then this point here. Okay. So I'll leave that to you guys to find what those values are. But this should give you an idea, right? When you have a function drawn, okay, you can then go on to find all the necessary values. So now in the next part, we're going to be finding for which values of x is our function g of x strictly greater than 1. So now let's see here, right? If we go back to our function here, okay, and let's draw a horizontal line. Okay, we want to see where that line is. Okay, so it's gonna be, it's basically gonna go past that point there, right? But let's just put a different color here. Okay. That color, maybe just green. Okay, so here what we want to do, we want to find values of x for which our function is greater than 1. Okay, so if we check here, right, where is our function greater than 1? It's going to be at this point here where it's touching this boundary here. You see this horizontal line we drew at that point here. But we haven't included like an equal to sign there, right? So it has to be strictly greater than x. So at that point there, it's x, right? Yep. So it's going to be x strictly greater than 0. Why? Because if you go towards the right, okay, for x greater than 0, you'll notice that our function is above this line here, okay, which is y is equal to 1. See, so having a function drawn, it makes it easier to visualize it. So now in the next question, 5.1.3, we want to write down the range of f of x. So the range of our function. So we can look at our function here, right? We can see that our parabola is bounded. So you see it doesn't go past this point here at -2. Okay. So we can already put a restriction here that y is greater or equal to -2. Okay, at this point here. So what this simply means is that our parabolic function is valid for any values of y which is equal to -2 or greater. So you see from this point here all the way up, our function is valid. So from this point here, going onwards. So -2, -1, 0, 1, 2, etc. all the way to infinity. So for that question, it's y is strictly greater equal to -2. Or you can even write it like this, okay? -2 all the way to infinity. So the square brackets here, it's inclusive of -2. Okay. The next question, 5.1.4. Describe in words the transformation of f of x to h of x is equal to that. Okay. So now let's see our function, parabola, right? It goes through a transformation from f of x to h of x. But what is the difference, right? Let us check what this output function is, h of x. It's x minus 2, x plus 2. So now here, if we multiply these terms out, what we'd get? X squared minus 4x it's actually going to be x minus 4, okay? Because minus 2x plus 2x cancel out. So now let us compare this, right, to f of x. So this here, if we break it down, it's going to be x squared minus 2 minus 2, right? So what I'm doing here is I just want to represent it in terms of f of x. So that bit there is f of x, okay? Because our function f of x is defined as x squared minus 1. So now here, if we write this in terms of f of x, we get f of x minus 2. So writing it this way, we can clearly see how these two functions are linked, right? So in order to get h of x, we took our original function f of x and then subtracted 2 from it. So what does that mean? It simply means that our function was moved 2 units down. Okay? So this here is an indication of that. So 2 units down, 2 units down. And that is basically it for question 5.1.4. So now let us go to the next one. So in the next question, we want to determine the equation of a function with asymptote -2 and the straight line f of x is equal to minus x intersects the graph of g of x at that point. So now let's break this down. Okay. Let's break this down a bit. So we'll have question 5.2. So we want to determine the equation of a function g of x is equal to a divided by x plus q, right? So this is a hyperbola and it has an asymptote y is equal to -2. Okay, and we are also given that f of x, which is a straight line, is defined as -x. And this function here intersects the graph g of x at 5 and -5. So, so what does this mean here? Okay, so we have two functions. We've got a hyperbola and a straight line. So these two functions, they intersect. So when they intersect, right, or cross, we simply equate the function to each other. Okay, so when we equate it, we can then substitute the points that are given. So for the hyperbola, we are given that the asymptote is -2, okay, which we're going to include now. Firstly, let's write down what we're given here, right? For g of x, we have a divided by x plus q. But what is that q? That q is the asymptote. Okay. So now we're going to replace q with -2. And then we equate to f of x, which is equal to -x. So now we're given one additional information, right? Which is this point here. So this is a common point where these two functions intersect, right? So we'll have, what are we going to have here? So the 5, okay, this x here represents 5, okay? So what we're going to have here is a divided by x is what? It's 5. -2 is equal to x is equal to 5. So we put -5 then. Okay. So now let us see here. So what we're going to have? We're going to have a over 5 is equal to -5 plus 2 is -3. Therefore, a is equal to -15. So what we had to do here is just solve for a. So the next part here is just to write down the final solution, because the output we want here is to write down the equation of our hyperbola. Okay. So now the output here would be what? Our function, since we've derived what the value of a is, we can then write down our function. So our function would be defined as -15 divided by x -2. Okay. So if we go back here to original function, which is represented by this, we can clearly see here that we have found all the parameters. And that is basically it for this question. But anyways, this was an educational video. I hope it helped you guys to understand the concepts. So I'll just leave it here for now, and till next time.